Alrighty, guys, welcome to section 4.2, writing equations in standard form. So we're learning three different kinds of equations for lines. You got standard form, you got slope intercept form, and you got point slope form. So right here, we're going to focus on standard form. And standard form is great for many different reasons. Graphing is not one of them, ironically, but it is useful for many other types of things, especially when we do systems of equations later on. So here it is. Standard form, it's one of the three forms, and specifically it is written as ax plus by equals c. So you have to have the ax term and the by term. So x and y have to be on the left, and the number, the c part, has to be on the right. And there are special criteria or rules that you have to have for a, b, and c. So here they are in this little block that we got from the book. So a has to be bigger than 0. So it has to start with a positive if it's there. And all three of them have to be integers, which means you can't have any fractions and you can't have any decimals. So one of the things when you're converting into standard form is getting rid of any decimals and getting rid of any fractions that you might have in the problem. So when you write down an equation, you write ax plus by equals c, and then you fill in. So the a value is going to be a number like 3, the b value is a number like 2, the c value is a number like 12. Again, it has to start positive, and all three have to be integers. So whole numbers, positive or negative. Well, a can't be negative, but b and c could be negative. Okay, moving right along. We'll take a quick look at some scenarios or examples where standard form is particularly useful. So a lot of times word problems lead themselves directly into standard form nicely. So let's do two examples where we define our variables and then we create an equation. So the price spent if you are buying sodas for $3 and pizzas for $8. So well, how much you spend is going to depend on how many sodas you buy and how many pizzas you buy. So let's define S equals sodas bought and P equals pizzas bought. Once we define these two variables, then we can say, okay, the total amount spent, I'll just write spent instead of defining a variable there, is going to be $3 per soda times the number of sodas. So $3 per soda times the number of sodas S. And then I have to add to that the money I spent on pizzas, which is going to be $8 per pizza multiplied by how many pizzas did I get? Well, we define that to be the variable P. So the total amount of money that I spent is going to be 3S plus 8P. So this is in standard form. It's 3S plus 8P equals, and then there's going to be a number here. Now, in this problem, it doesn't tell us like how much money we spent, but it would be an actual number like $10 or $50 or whatever it would be the number that goes here. So this is our A value is 3, our B value is 8, and our C value would be whatever number gets put in right there. Okay, second example, the amount of chicken eaten if each adult eats 3 pieces and each kid eats 2 pieces. Okay, so how much chicken gets eaten depends on how many people there are, right? So we can say that A equals the number of adults and K equals the number of kids. Notice instead of using X and Y, I like to use variables that represent what it is we're talking about whenever we're doing word problems. It makes it a little easier to follow along when you're doing your work because you know what it represents just by looking at it. So again, the amount of chicken, so I'll just say amount equals, so 3 pieces for each adult. And how many adults do we have? We have a number A. So 3 pieces times a number of adults plus the kids eat 2 pieces each. So 2 pieces multiplied by the number of kids is K. So I could rewrite this as 3A plus 2K equals some number, which is again the amount of chicken, where just like before, in an actual problem that you were given, it would maybe tell you that number or you'd have to figure out that number. But I hope you can see that each of these two is written in standard form. You've got your A, you've got your B, and you've got your C. And when you're setting up word problems like this, where there's a couple different things happening and you're combining them together, writing the equation like this in standard form is almost always the easiest way to approach the problem. Okay, let's just take a quick look at what's last. So what about not word problems, but just pure mathematics, converting back and forth between slope intercept form that we learned about before and standard form, which we're learning about now. So if you want to convert something into standard form, you got to move the X and Y terms to the left-hand side. So for example, over here, we got to get this 3x over on the other side. So we're going to go minus 3x minus 3x. And that's going to give us negative 3x plus y equals 5. But remember, we're not allowed to have a negative in the front, so I have to multiply the entire equation by -1 to cancel out that negative that's in the front there. And that will leave me with 3x minus y equals -5. So I just multiply everything by -1 so that my leading term is positive, because one of the rules for standard form, again, is that the first value, the ax value, has to be positive integer. Okay, so let's look at the second example here. Just like before, I have to move this over. So I'm going to add 1/4 x onto both sides of my equation. And now I have 1/4 x plus y equals 4. So it is positive, which is great, but it has a fraction. And the other thing to remember is you're not allowed to have fractions or decimals. So we're gonna have to multiply the entire equation. To cancel out a 1/4, I'm gonna have to multiply it by 4. And then I distribute that 4 into my equation. And when I distribute that in, I'm gonna get x plus 4y equals, sorry, that's supposed to be equal sign 16. So I distribute the 4 in here, it cancels out the 1/4. I distribute it in here, I get 4y. Distributed in here, I get 16. So you can check this is correct because it's got only integers as coefficients, and the leading term is positive. Okay. When you convert the other way, you're basically just solving for y. You're trying to get y equals something. So you're going to move everything to the other side of the equation. And I think we've done a lot more stuff similar to this. So to get y by itself, we're going to subtract 3x on both sides. So now we're going to have minus 4y or negative 4y equals negative 3x plus 8. And then we can divide both sides by -4. You don't have to color code your work, but I'll try to color code it just to keep things nice and clean here. So you can see in red is the thing that we did. So negative 3x divided by -4, the negatives cancel out because negative divided by a negative is a positive. So I'm 3/4 x minus 2, because positive 8 divided by -4 is -2. So we can now look and say, hey, the slope is 3/4 and the intercept is -2. And that's useful and helpful if you have to graph this, or if you have to identify the starting value or the slope or the rate of change, that kind of stuff. Okay, second example. We're gonna, again, just move the 5x to the other side. And then see what we get here. So 3y equals -5x plus 15. Try to get into a good habit of writing your expressions with the variable first and the number second. That's just a nice way to be conventional, and so it's easy for everyone to follow along and have the same thing. After we move the -5x to the other side, we are going to divide both sides by 3 to cancel this 3 out. And we get our final answer nice and neat here. -5/3 x plus 5. So when you divide -5 by 3, you can't reduce the fraction, so you can just leave it as -5/3. So that's going to be our slope, -5/3. And then the 15 divided by 3 is 5. That's going to be our y intercept. So converting back and forth, it's good practice on the things we've been doing, but it's nothing too crazy. And then converting equations into that from word problems is also something we reviewed. So in class, if you have questions or anything like that, mark it in your notes, please, and then ask in class, and we can go back through and do more examples. So I'll see you in class.